Yeah. Hello everyone, welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. Right. Today we are going to discuss about the topic of geometry. Okay? Right. So, and what is the meaning of geometry? According to the geometry, in Greek language, geo means earth. Geo means earth. Metric is nothing but measurement. Okay, na? So while you are observing that geometry is nothing but the measurement of earth. Not only exactly measurement of earth, the shapes, the regular shapes which are available on the earth, we can measure by using this topic. Okay, na? And it is introduced by famous Greek mathematician Euclid. Euclid is introduced about this topic. So that's why we can call this one as Euclid's geometry also. Okay, right? And basically, the Euclid is derived three terms. Mainly, three terms. They are called undefined terms. There are three undefined terms are there. They are nothing but line, point, line and plane. That means there is no exact definition of point, line and plane. They are usually taken from the real life situation. Okay, so there is no exact definition of point, line and plane. These three terms are not defined, but to define any other related geometrical object, we are using these concepts. We are using the point, we are using the plane and we are using the line to define other geometrical terms. But these three terms are taken from the real life situations. Okay, no? Right. Now, what is point? Point is nothing but it is an object to locate or to tell the position of an exact location. Okay, na? It is having only properties, because I told you already these three are undefined terms. There is no exact definition of these three terms, of these terms: point, line and plane. Clear? Yeah. So point is used to tell to represent an exact location. Clear? And there is no thickness, because here point is no dimensional object. Point is no dimensional object. That means there is no thickness, there is no length, there is no breadth. It is a just dot to represent a location or to represent a place. So that's why we are using the capital letters to represent point. Okay, because there is no thickness, there is no length, there is no breadth. Okay, right. So that's why we can call the point as no dimensional object. Okay, right. Now coming to the plane, plane is a one dimensional object. Here point have no dimensions, but plane is one dimensional object. It is having only one dimension. What is the dimension? That is length. The one dimension is length. We can call breadthless length also. Breadthless length. Okay, na? So one dimensional object, and the plane or the line can be, sorry, I'm talking about the line. Okay, the line is a one dimensional object. The dimension is nothing but line. And this is the symbol for line, a straight line. It can be extended on both directions. The arrow mark represents the continuity of line. Okay, so we can extend it towards the right hand side or left side. Okay, and you can place number of points on a line. How many? There are infinite number of points. How many number of points we can place it on a line? Infinite number of points, because the point does not have any dimension. It doesn't have any dimension. So we can keep number of points on a straight line. And there is no end point for the straight line. There is no end for that. That means the arrow marks are represents there is a continuity both sides. That means the line has no end points. But we can place infinite number of points on a line. Infinite number of points on a line. Clear? Yeah. And the line we can call line AB. We are represented with this symbol line AB. That means A and B are any 2 points on the line. A and B are any 2 points on the line. There is no end point for the line. Okay. Now coming to the third one, plane. Plane is two-dimensional object. Plane is two-dimensional object. So what are the two dimensions here? Length and breadth. The two dimensions are nothing but length and breadth. You can take a best example for the class board. This board. It is having the length as well as breadth. Okay? Yeah. So it is a two-dimensional object, and that too we can take it as a plane as a surface of a wall. If you take a wall in your room, the wall surface we can consider as a plane or flat surface. Okay? And the line from the room you can take it as edge. Edge is nothing but the combination or connection position of any two planes. Okay? Na? Edge. Edge is the best example for line or a line segment. So what is line segment? Let me continue that. When we discuss about the line, I told you that there is no end point for the lines. But if you take any one of the part, a small piece from the line, we can consider it is a line segment. So simply, line segment is nothing but part of a line. So from this entire line, just I am removing this part. It is having both sides end point. That means the line segment is starting from A and ending to B. A is a starting point, B is ending point. The line segment is nothing but part of a line. Line segment means part of a line. Here also we can keep infinite number of points. We can keep infinite number of points on this line segment. Okay? And how many endpoints it is having? 2 endpoints. And we can call this line segment AB with the symbol AB line segment. AB line segment or line segment AB. Okay? Right. So 2 endpoints and it is a part of a line. Now coming to the one more, that is ray. Ray is also a part of a line. Ray is also a part of line. But ray is having only one end point. Ray is having only one end point, and another side it can be continued like that. There is no second end point for the ray. Line segment having 2 end points. Ray is having only one end point, and line does not have any end points. So similarly, we can keep infinite number of points on the ray also. Infinite number of points on a ray. But we are discussing about the line and line segment. See here, line AB we can represent like this. Line AB or line BA both are same. As well as line segment AB or line segment BA both are same. But ray AB and ray BA are not same. Because ray AB is, A is a starting point or A is an end point. Only one end point it is having. And another side, it is continuity will be there. So ray AB and ray BA are different. These two are different. Okay, na? Here B is the end point, here A is the end point. Both are different. But line AB, line BA are same. Line segment AB, line segment BA are same. But according to the point of ray, it is not same. Okay, na? Yeah. So we discussed about the undefined terms are nothing but point, line, and plane. Again, coming to the line, there are two more. That means there are the parts of the line, nothing but line segment and ray. Clear? Yeah. Plane is a two-dimensional object which are having length and breadth. Okay. Now let us discuss about the collinear points. Collinear points. What are collinear points? We know about the point. There is no thickness, there is no length, there is no breadth of a point because it is no dimensional, zero dimensional object. Am I right? And when you coming to the collinear points, we are taking some points. If all the points are being on a single straight line, then we can call these points are called collinear points. Okay, na? What are collinear points? Points are lying on same line. So simply points lies on same line are called collinear points. That means if you are taking a line like this, we can take number of points on the line. So these are all points are called collinear points. Now you have taken two more points G and H. These two are not lying on a same line. Okay. So A, B, C, D, E, F are collinear points. G and H non-collinear points. Points lying on same line are called collinear. Points not lies on a same line are called non-collinear points. Okay, na? Right. Now let us discuss about that coplanar points. What are that? Coplanar. Plane means two-dimensional object which is having length and breadth. Coplanar is nothing but the points which are lies on a same plane. That means I am taking the number of points on this board. These are all called coplanar points only because these all points are based on lies on the same plane. For example, if you take if you are keeping some points on one of the surface of your room or one of the wall of a room, and some other points you are keeping on some other wall, another wall, then the points, all points are on the same plane are called coplanar points. Some points are being here and some points are being on another wall. They are not coplanar because they are being on different planes. Okay, na? Plane is nothing but a surface. Okay, right. So coplanar means the points lying on a same plane are called coplanar. Okay, right. Now non-coplanar also we discussed and non-collinear points also discussed. Non-collinear points not lying on a same line are called non-collinear points. Yeah, and coming to the line and line segment and ray, we need to discuss one more point, that is, while you're given that line AB line has no fixed length. Line does not have fixed length because the line can be extended both sides. It represents with the arrow marks. That means it is not fixed length. We can extend towards right side and towards left side. Both sides we can extend. That means it does not have any fixed length. Same way ray if you are taking that, ray also can be extended one side. Ray also can be extended one side. From here, one point to it can be extended like this. That means there is no fixed length for ray also. But line segment having the fixed length because it is bounded by 2 points. Okay, now. So starting point, ending point. There is a certain fixed distance for line segment. Line ray does not have a fixed length, but line segment have a fixed length. Clear? Yeah. So now let us go to the topic of Yeah, line, plane we discussed already. Yeah. So let us go to the concept based questions, nothing but practice sheet problems. Let us see. And before that, let me discuss a point, that is, for example, if you take a line or if you take a point on a plane, any plane surface or any flat surface, if you are taking a point like this, how many lines you can draw or you can able to draw from this point? How many lines you can draw? So horizontal line, yes, one line I can draw through this point. We can draw vertical line also, two lines. Yeah, slant line here, 3, 4, 5, 6, 7, like that. We can draw infinite number of points through single point. Sorry, infinite number of lines through single point. Okay, na? How many number of lines can be drawn through a point, one point? There are infinite number of lines are there. Okay, or if you take any 2 points, we can draw only one line. Only one possible line can be drawn through 2 points, but only one point we can draw infinite number of lines, but 2 points we can draw only one line. If you take 3 lines, 3 points, there is a chance of possibility and there is no chance also, because if the 3 points are being on a same line, we can draw one straight line. If the points are non-collinear points, there are 0 lines can be drawn through these 3 non-collinear points. If the 3 points are collinear, we can draw only one straight line. If these 3 points are non-collinear point, we are not able to construct a line through these 3 points. Okay, 0 lines. Yeah. Let us go to the concept based questions. So simply practice sheet. Yeah. So till then we discussed about the geometry concepts, undefined terms, and some properties of the undefined terms: point, line, plane, and again in the line segment and ray we discussed, non-collinear points we discussed, and collinear points, non-coplanar points and coplanar points, all we discussed. Let us see some of the related questions. Okay. Now the first question is given that the line segment contains dash points. Line segment contains, that means if you take a line segment, how many points a line segment has? So I told you already, line segment is nothing but a part of a line. But the question is clearly, you should read clearly, because the question is not framed like how many end points does a line segment has. We are not discussing about end points. We are asking about how many points contains a line segment. That means how many points we can keep it on a line segment. There are infinite number of points. How many end points? The question is asked like how many end points? The answer is 2. For line segment there are 2 end points, but the line segment contains infinite number of points. Okay? Yeah, let us go to the second question. The second problem or second concept based question is, a line has dash endpoints. How many endpoints does a line has? Is it having endpoint here? There is no endpoint for line. So the answer is 0 endpoints. Answer is 0 endpoints. And what is the question number 3? The question number 3 is given, a edge of a box represents. Edge I told you while I'm discussing about the concept of line segment and ray. Edge is nothing but considering as the connecting part of 2 walls in your room. Okay, na? One surface with another surface, both are connecting at a place. That place is looking like a line segment. Okay, na? So the edge is nothing but line segment. or we can consider as line also, that depends. So mostly line segmenting. Right. Now let us go to the question number 4. The number of endpoints on the line segment. Line segment, how many endpoints? It is having 2 endpoints. Line segment having 2 endpoints. Okay. Now question number 5. Only concept based questions is what? Through a single point on a plane. If you take any one point on a plane, then we can draw dash lines. How many lines we can draw? I told you already, there are infinite number of lines can be drawn through a point on a single plane. Okay. Now let us go to the problem number or the question number 6. 1 millimeter equals to. So before that, we need to discuss about the measurements first. What are the measurements we know actually? Lengthwise. Lengthwise, there are certain measurements. The smallest measurement or main unit measurement is meter. Okay, na? Because all we are expressing in the terms of meters only. Among them, smallest measurement is millimeter. Millimeter is nothing but while you are observing a ruler or a scale, there are centimeters will be given. That means in that 1 centimeter, while you are observing the scale here 0 to 1, here 1 to 2, 2 to 3 like that, there are lines will be there. Okay, now from 0 to first line, the gap is called millimeter, length of millimeter. That means 1 centimeter, there are 10 gaps will be there, nothing but 10 millimeters. Here smallest measurement is millimeters. So from this we can say 10 millimeter equals to 1 centimeter. So 1 centimeter, 2 centimeter, 3 centimeter like that. If you are taking that 100 centimeters, it will be 1 meter. 100 centimeters equals to 1 meter. Same way, 1000 meters equals to 1 kilometer. Okay, na? Actually, meter, millimeters, centimeters, decimeters, meters, decameters, kilometers, like that will be there. But we are just discussing about the millimeters, centimeters, and meters. Okay. Now the question is, question number 6 is 1 millimeter equals to dash centimeters. Actually, millimeter is bigger or centimeter is bigger. Let us see. We know that 10 millimeters equals to 1 centimeter, but you are asking about only 1 millimeter. 1 millimeter we want, but here we have 10 millimeters. So this 10 is multiplying now. So this 10 I can write as 10 into 1. Can I write? 10 ones are 10. Yes. 10 into 1 I can write, that is equals to 1 centimeter. The multiply 10 transpose, that is, it is going to divide. So 1 by 10 centimeters. 1 millimeter equals to 1 by 10 centimeters. If you want to convert this 1 by 10 into decimal form, it will be 0.1 centimeter. 1 millimeter equals to 0.1 centimeters. Okay. Now let us go to the question number 7. The 7th question is given that the number of lines that can be drawn through a non-collinear points. The number of lines that can be drawn through a n non-collinear points. There are n non-collinear points will be there. How many lines? So we can draw different number of lines are there. Am I right? Each point we can draw infinite number of points. Sorry, infinite number of lines. Yeah, number of lines that can be drawn through n non-collinear points. N lines we can draw. Yeah. Let us see the formula which is given here. I think there is a formula is given, that is n into n plus 2 by 2 and n into n minus 1 by 2 and n plus 1 by 2, like that so many are given. N plus 1 by 2 or n minus 1 by 2. So, but the number of line segment or number of non-collinear points can be drawn is n into n minus 1 by 2. The formula for number of line segments or number of lines can be drawn through non-collinear points is n non-collinear points is n into n minus 1 by 2. Let us try. To tell about the collinearity, how many minimum number of points we should take first? How many minimum number of points? Minimum 3 points must be there, because if you take only 2 points, we can draw one line definitely. Any 2 points we can draw one line. If you take any 2 points, we can draw one line. That means the 2 points are lies on a same line. Lies on a same line means will be collinear points only. That's why minimum number of points to decide or to discuss about the non-collinearity or collinearity is 3 points. That means if I draw like this 3 different points, how many line segments we can draw? These 2 we can draw, and these 2, by using these 3 points we can draw one line segment. Here one line segment. How many total? 3. 3 points we can draw 3 line segment. Is it possibility or are any other points are there or any other non-collinear points? Sorry, any other lines we can draw or line segments we can draw here? Let us see the formula. We got only 3 line segments, right? So if you substitute here in the place of n, n means 3 non-collinear points. So 3 into 3 minus 1 by 2. That is equal to 3 into 3 minus 1 value 2, 2 by 2. So 2 cancel, number of line segments are 3. If I am taking 4 non-collinear points, let us see that formula. 4 into 4 minus 1 by 2. Okay, that is equals to 4 into 4 minus 1 value is 3. 3 by 2, 2 table in 4, 2 times 2, 3 are 6. There must be 6 lines we should draw. Let us check the 6 line segments. So 1, 2, 3, 4. For 4 points, I am naming the points as A, B, C, D. 4 different points, 4 line segment I can draw. And these 2, AC is a line segment. A and C non-collinear points here. BC also line segment, BD also line segment. Total 6 line segments are there. So the possibility of the formula is n into n minus 1 by 2. Okay, na? So number of line segments can be passing through non-collinear points or n non-collinear points formula is n into n minus 1 by 2. Okay? Yeah. Let us go to the problem number 8. Yeah, eighth problem is given that two different lines in a plane have a common point. One common point. Let us discuss about the plane. If you take a plane, we can draw 2 line segments or 2 lines can any manner. That means we can draw one line like this, we can draw one line like this. Then when you extend this line, these 2 are going to intersect at a point. This is called common point between the 2 lines. This is one of the chance. 2 lines can be intersected. Okay, na? The way of drawing 2 line segments on a plane, they both can be intersected in any manner. That means these 2 can intersect like this, or both can be intersect like this as a shape of X, or both can be intersect like this. Whatever. There are multiple options, but they definitely intersect. One chance is intersecting, and the second chance they are never intersect. Like a railway track, we can take a parallel lines, they never intersect. That means there is no common point between them. No common point between 2 rays or 2 lines or line segment. That 2 lines are called parallel lines. Okay, na? There is no common point between parallel lines. And coming to here, there is one common point. One common point is nothing but intersecting lines. One common point is nothing but intersecting lines. One more option is there. That is, if you take one line like this and another line also lies on this. Then how many common points will come? There are infinite number of common points. Then this type of lines are coincident. Okay, na? What lines? Coincident lines. That means both are coincide each other, one on another. Okay, only three situations. First one, they can be intersect lines, they can be parallel lines, they can be coincident lines. Okay, only one common point for intersecting lines, zero common points for parallel lines, infinite number of common points for coincident lines. Okay, na? Yeah. So what is the question here? The question is the line or line segment. Yeah, two different lines in a plane have a common point, one common point, then we can call such type of lines are intersecting lines. Which type of lines? Intersecting lines. Okay. Now let us discuss about the ninth question, cross observation question. That is the common point of concurrent lines is called. Then what is concurrent lines, sir? We discussed about the intersecting lines we discussed, and parallel lines we discussed, and coincident lines we discussed. But what are concurrent lines? Only two lines are having a common point. Only two lines are having a common point are called intersecting lines. But if you draw more than two lines at same common point, such type of lines are called concurrent lines. Okay, na? What are concurrent lines? More than two lines having a same common point or having a common point are called concurrent lines. Only two lines are having a common point, intersecting lines. Okay, the common point of concurrent lines is called point of concurrency or concurrent point. We can call concurrent point. Intersecting point here, concurrent point or point of concurrency. Right. Now question number 10, that is in a solid the number of vertices, number of faces and number of edges. So actually faces, edges, vertices, these are all belongs to three-dimensional objects. But until then we just discussed about the single dimension, no dimension object as well as two-dimensional object. Okay, na? Plane is considering as two-dimensional object, line is single dimension object, point is no dimension object. Okay. Yeah, here vertices, plane and surfaces or faces, whatever, it is given in three-dimensional object. Now let us discuss shortly about one of the three-dimension object. And here one of the famous mathematician Euler. One of the famous mathematician Euler is derived about the flat surfaces in three-dimensional shapes. Three-dimensional shapes, not for all the three-dimensional shapes, only the shapes which are having flat surfaces. Okay, na? For example, cube, cuboid, these are having only flat surface, not curved surfaces. That means, yeah, while you're taking about the cube like this, cube having six faces. What are the six faces? There is one front face, here back face, right side and left side, four faces, top and bottom, six, total six surfaces. Okay, na? Cube having six surfaces, nothing but six faces. Okay, na? Now talking about the edges. Edges, I told you the line segment or the connecting line between the two faces is called edges. Now while you are observing that in the cube there are 12 edges. What are the 12 edges? See here. I am drawing here the same cube. Here 1, 2, 3, 4. That means in the top surface there are 4 line segments. And the bottom surface also there are 4 line segments. Here 4, here 4. Okay, na? In this 4, 2 lengths, 2 breadths are there. And here 1, 2, 3, 4. Total 12 edges. How many number of edges are there? There are 12 edges. And the corners are vertices. Vertices are nothing but corners. Corners, while you are observing the corners, there are 8 corners. See here. First corner, second, third, fourth. Top 4 corners, bottom 4 corners. So total 8 corners, nothing but 8 vertices. And what that Euler derived while you taking that any 3-dimensional object which is having the flat surfaces are all follows a rule, that is faces plus vertices equal to edges plus 2. Here F means faces, V means vertices, E means edges and plus 2. Every 3-dimension object which is following or which is having a flat surface or follows this Euler rule. That Euler rule is faces plus vertices equals to edges plus 2. Okay, now let us check here. Faces. Let us take the cube. Cube is a flat surface. How many faces? There are 6 faces. How many vertices? There are 8 vertices. How much 6 plus 8? 14. That must be equals to edges plus 2. Edges how many? 12 edges plus 2. 12 plus 2, 14. 14 equals to 14. And I told you, right, we are discussing about the flat surfaces. The 3-dimensional object having a flat surfaces are called, are having the Euler formula. That type of solids are called polyhedrons. What they are called? Polyhedrons. That means the 3-dimensional objects having flat surfaces are called polyhedrons. Okay, na? Right. All polyhedrons are follows the rule, Euler formula, that is faces plus vertices equals to edges plus 2. And the 10th question also given based on that same condition, the same concept. So you can identify that the faces plus vertices is equals to edges plus 2. So first option. For 10th question, it will be first option. This is the answer. Faces plus vertices equals to edges plus 2. Okay. So until then, concept based questions are completed. Let us continue the class in our next coming period. That's it for today, children. Thank you one and all. Have a nice day. Bye bye.